Make a shape out of this Play-Doh for me.
Alright.
Okay. Now what can you tell me about how the mass has changed?
Well, I would say that the mass has decreased.
Explain to me why that is.
Well, before it was a blob of Play-Doh and it was large, and
Okay.
now the width of it has narrowed, so the mass is most likely smaller, so it's decreased.
Okay. So what can you tell me about the properties of matter, of an object?
Well, I would say that objects can change shape, based on if I can change the shape of an object.
Okay. Now we're going to go ahead and weigh this. So we're going to take the mass of this object. So the mass of this was 140 grams. Okay? So now I want you to make it back into a ball. Now how do you think the mass has changed?
So I think when we weigh it the second time, it's going to be bigger.
Okay? Let's go ahead and weigh it.
That's perfect.
Okay. It was 140 grams. So how have your previous thoughts about the mass of an object changed?
Well, I was obviously wrong. The object stayed the same both times. I'm not really sure why, but the object, even though it looked different, it stayed the same.
Okay.
Mass.
Mm-hmm. Okay.
We're taking the mass of this.
Okay. So here's a formation of Legos. Now I'm going to start by taking the mass of this. So the mass of this object was 70 grams. Now I want you to break it apart so that none of the objects are touching, none of the Lego pieces.
Alright.
Okay, how do you think the mass has changed?
Well, I think that it might have changed just because it looks different.
Okay.
But also, it's the same amount of Legos than it was when it was all connected than when they are all apart.
Mm-hmm.
So it might actually stay the same since it's the same amount of Legos, but I'm not sure if the space or the air around it has something to do with that, so that could affect the mass as well.
Okay, I'm going to go ahead and take the mass of all of these. I'm just going to take all of these pieces. And the mass of all these pieces together was 70 grams. How does that affect your predictions?
Well, I would say I was kind of on the right track that even though it physically looked different and also was separated physically, it was still the same because the same amount of Legos was used the first time and the second time. Therefore, the mass stayed the same because nothing was added or taken out. There was no Legos that were added or taken out.
Okay. Now I just have one more thing I want you to do. Okay. So there's some water in this water bottle. Okay. So what do you think would happen if we put this in the freezer?
Well, the water in the water bottle will freeze.
Okay. And what do you think will happen to the mass?
Well, I don't exactly know what happens when it changes states.
Okay.
But I think it might stay the same just because it's done on the other problems before, that it might stay the same even though it looks different.
Okay. I'm going to go ahead and take the mass of it. So the mass of this water bottle with the water in it is 224 grams.
Okay.
Now I'm going to put it in the freezer, and we'll check it in a few hours and see what happened. We'll remass it then. So what do you think will happen to the mass of the water bottle with the liquid in it after it changes states?
Okay. Well, I think that I don't exactly know how states work, like I was saying, but yeah, I think that it might just stay the same.
Okay, let's go ahead and try it. Okay, so here's our frozen water bottle. Now what do you think happened to the mass of the water when it changed state? Just as a refresher.
Well, I think that it stayed the same.
Okay. Okay, well, let's mass it and let's see what happens. And the mass was 224 grams.
Yeah.
So what are your final thoughts on what just happened?
Well, the only part I was kind of confused about in the beginning is when it changed states. I wasn't sure if the mass was going to change. But when I think about it, nothing was ever added to the water bottle and nothing was taken out. Therefore, the mass didn't change even though it changed from state. So even though it physically looked different and it changed state, the mass still stayed the same.
Okay.
Here's a ball of play-doh. Here you go. I want you to make a shape out of that play-doh.
Okay, I'm going to make a flat pancake.
Okay. What do you think happened to the mass of this object?
I think it increased.
Why do you say that?
I think it increased because it's bigger than it was before.
Okay. So, what can you tell me about the physical properties of an object then?
You can manipulate the shape of an object to make them look different.
Okay. So now, I'm going to mass this object, and I'll be right back.
Okay.
Alright, so I found out that this is 140 grams. So now I want you to put it into a ball again.
Alright.
Great. I'm going to mass it again. So, it turned out that it's also 140 grams. Have your previous thoughts changed?
Yeah, they did. It stayed the same, but I don't really understand why.
Okay. I have this block of Legos right here, and I'm going to mass it. Okay? Okay, so this block of Legos turned out to be 55 grams. Could you take apart the pieces so they're not touching each other?
Okay.
Okay, so what do you think changed about the mass?
I think the mass decreased because there's air in between all the pieces now, and they're not all clumped together, so that would change the mass and lower it.
Okay, so now I'm going to weigh all these pieces separately. I'll be back. Okay, so I massed the pieces of blocks, and they turned out to be 55 grams. So what does this change about your predictions?
Well, I guess I was wrong. I mean, I guess the air doesn't have anything to do with it. It didn't change the mass at all. I thought it would decrease, but it didn't do anything.
Okay. So now I have one more thing for you to look at and to think about.
Alright?
So here's a water bottle with some water in it. What do you think will happen to the mass when it turns from liquid to solid?
Well, I think that mass will decrease, even though there's the same amount of water in it. I think the freezing process will contract it.
Okay. Well, let's try it.
Alright?
I'll mass it. Okay. So it turned out that the mass of this water bottle is 224 grams.
Okay.
So I'm going to now freeze it and see what the mass turns out to be then.
Okay.
Okay, so again, what do you think happened from the mass before and after?
Well, like I said before, I think that the mass would probably decrease, even though there's the same amount of water in there. The freezing process probably would contract it or something.
Okay. All right, so let's mass this and see what happens.
Okay.
Okay, so turns out that the mass of this water bottle that's frozen is 224 grams. So what can you tell me about that?
Well, I guess I was wrong. I thought the mass would decrease, but even though there's the same amount of water in there, that never changed. And so, though the physical state changed, that doesn't change the mass of the object.